observed from the north and south poles. Total solar eclipses happen about once every 1.5 years. Nearly identical eclipses, total, annual, or partial, occur after 18 years and 11 days, or every 6,585.32 days, the Saros cycle. The Saros cycle exists because it takes 18 years and 10 days for the entire orbit of the moon to process once around it in its orbit plane, so that the lunar nodes make one complete revolution along the orbit. This nordical period equals nearly an integer number of lunar months. 223 times 29.53 days equals 6585.19 days during each Saros cycle. Because the true length of the Saros cycle is 6,585.32 days, you have to wait 3 Saros cycles in order for an eclipse to repeat at the same spot on Earth. Successive eclipses in the Saros cycle happen a third of the way around the world from each other, and after 3 Saros cycles, the eclipse returns to nearly the same geographic location after 54 years and 33 days. 12 different grand Saros eclipse series are now occurring, with one producing the eclipses of 1937, 1955, 1973, 1991, and 2009, having durations near the 7.5 limit. Every eclipse begins at sunrise at some point in its track and ends at sunset about halfway around the world from the start point. Partial solar eclipses can be seen up to 3,000 miles from the track of totality. Before the advent of modern atomic clocks, studies of ancient records of solar eclipses allowed astronomers to detect a 0.001 second per century slowing down in Earth's rotation. Total solar eclipses happen because the Sun is near one of the nodes of the lunar orbit, and the Moon is at the perigee at this node at the same time. Annular solar eclipses happen because the Sun is near one of the nodes of the lunar orbit, and the Moon is at the apogee at this node at the same time. Shadow bands are often seen on the ground as totality approaches. Light filtering through leaves on tree casts crescent shadows as totality approaches. Local animals and birds often prepare for sleep or behave confusedly during totality. Local temperatures often drop 20 degrees or more near totality. During totality, the horizon is illuminated in a narrow band of light because an observer is seeing distant localities not under the direct umbra of the moon's shadow. A total solar eclipse is one of the most spectacular astronomical events. It occurs when the moon passes between the sun and the earth. For a short system from above the Earth, you would see that during its orbit, the moon passes between the Earth and the sun. If you viewed the solar system from the side, however, you would see that the moon's orbit is not always in line with the sun and the Earth. That's why an eclipse doesn't happen every month. Approximately once in every 7 orbits, the Earth, Moon, and Sun line up, and a solar eclipse occurs. The diameter of the Sun is approximately 400 times larger than that of the Moon, but when you look at the Sun or the Moon from Earth, they appear to be the same size. This is because the Sun is almost 400 times farther away, a strange cosmic coincidence. Not every solar eclipse is total. If the Sun and the Moon don't line up perfectly, then only a fraction of the Sun is covered. This is called a partial solar eclipse. The area experiencing a total solar eclipse will be in darkness because the moon blocks any sunlight from reaching the Earth. This temporary darkness is known as the Penumbral Shadow, and it's usually a path less than 100 kilometers in width. Because the moon and the Earth are always in motion, the shadow also moves. That's why a total solar eclipse doesn't last forever. In fact, viewed from any one place, it is never longer than 7 minutes. People watching in an area outside but close to the umbral shadow will see a partial total eclipse. This is known as the Penumbral Shadow and is much larger than an umbral shadow. Partial solar eclipses